Hi there everyone, welcome to my version 2 of the Assassin's Creed Hidden Blade. This design is a little bit different from the first one in that I've completely scrapped the OTF mechanism, which I think is what was causing a lot of the problems that you guys described in the comments. 3D printed parts in general I find just aren't strong enough. You have tolerancing problems that you get when you try and print them, so things don't mesh properly or don't line up properly. There is also like weakness in material, flexibility, things like that, which can sometimes lead to a result that you don't want. Parts breaking, parts not functioning as they should, all that sort of thing that I've seen in the comments and in my DMs, and I kind of wanted to get around that. The easiest way that I could think of was starting from scratch, coming up with a design that didn't have so many moving parts, so many things that required on tight tolerances, things like that. So in this video I'm going to try and break down how it works, just so you have an idea when you're putting it together. I will do a full assembly video like I did the first one, but for now I'm hoping this will be enough for you guys to actually make your own. The most significant change that you'll notice is that there is a gear train mechanism here rather than the OTF I mentioned earlier. It looks really complicated looking at the view like this, but really it's quite simple and I'm hoping I can break it down for you. So everything here and here are just aesthetic pieces. They're just to make it look a bit sleeker and not so flat. In addition to that, this wheel here, this is actually not required, but I won't remove it just yet so that you can see it where it's situated in the assembly later on. But as in my previous design, it's essentially just a case with 4 strap points and a blade sticking out the end slightly, just so you know which way to come out. This design is a little bit thinner than the other one, in that it is a total of 15.5mm from these 2 blue surfaces here, where I believe the old one was something like 23, so it's quite a bit skinnier, a bit more easy to conceal if you're doing cosplay or anything like that, and just a nicer thing, doesn't look so bulky. So how does it go together? Well, there's a little case here, which there are some fixings which I hid earlier, so the whole thing is fixed like the previous design with M2x10 posi head screws. It doesn't really matter what screw you use, to be honest with you, but I would recommend M2 just because I've printed the holes to be that size thread. So I'll just hide those real quick. So how does it work? Well, like all hidden blades, it has a case design, and it's just a hub for everything. There's nothing really that special about it. It is a little bit different from the last one. You notice there's no channels for hammers anymore, there's no room for elastic bands, there's no locks. This hidden blade is actually designed more after Altair's from the first game, where it will only extend as long as your finger is pulling tension on it, and as soon as you release, will shoot back in. I have found it's possible to make it sort of jam and stay out, although this isn't intended and is likely just something snagging somewhere on my prototype, but it is intentional that it's supposed to go back in when you release tension. I appreciate that this isn't the design that people like sometimes, and a lot of people like the locking dual action mechanism that OTFs bring, but I personally find them a bit more complicated than they're worth. They tend to break easily, you don't get many fires out of them before the bits degrade like the elastic bands, or the locks slip out of position, that sort of thing, and I think the payoff just really isn't that worth it. PLA with 3D printing isn't really that suitable for that sort of mechanism because over time you get creep, you'll get deflection in the plastic, on the arms of the hammers, things like that. So unless you have access to an industrial lathe or laser cutter, I don't think it's really that useful to make it an OTF system. This system is a bit more simple, so I'll try and go through it with you now. On top of this hub piece, you will see there are 2 platforms there, and the piece that sits on top of them is what's known as the gear rail, which is this piece here. There's nothing really that special about it. It is a flat piece of plastic, if I open it up here, that has some cylinders extruded on it, a slot here which we'll get into later, a little cylinder here for an elastic band, and this little pin here is where the aesthetic wheel sits that I mentioned earlier. Moving back to the main model. So on top of that, I will show that little wheel that I was on about, which is known as the pulley, which is this blue part here. It used to be that there was a string going all the way around the model, like in the other design, but I found that this pin here started snapping no matter what infill I printed it at, and this just caused a lot more problems that I mentioned in the OTF mechanism. I did end up keeping it though, just for the aesthetic of having a wheel in the back. If you ever chose to modify it and make it spin, by all means go for it, but at the moment it just sort of serves as a little aesthetic piece that makes it look a bit more intricate than it is. Next up is the main piece, the blade. So I'm just going to very quickly show the blade. This one is a little bit simpler than the last one in that it doesn't have these notches in the bottom for the locks or anything. It's just a rectangle with a tapered end, and you'll see there's some little teeth here for gears, which we'll get into in a bit. The blade just slides in the bottom here, or in that little slot, and just sits there nice and tight. Once you've installed the blade, we have to do a little bit of sub-assembly. So there are two pieces. One is called the drive rack, which I'll show now, and one is called the band plug, which is this part here. There's nothing really too special to note about the assembly of these parts. This piece here just sits nice and snug in that little rectangle, or slot rather, and to be honest, just gluing it or using any sort of fixing method that you want will work. I would personally recommend Gorilla Glue just because it doesn't, you don't have to screw anything, and there's not as much residue, just that sort of thing. A little dartboard here, it's just got to be strong enough to not rip apart with an elastic band, and that's all. So I'll just show that again. Once you have that, this here is essentially what's going to turn all the gears. So in principle, between this surface here, you'll notice there's a little gap here. An elastic band is going to hoop around there and loop around here, and that's going to create the tension between these two parts as this bit slides. You'll notice that there are some teeth on here, and as you can probably imagine, there's going to be a gear here. So the gear that is there is the piece that I've called the trigger gear. The trigger gear is a little bit different from the others in that it's a compound gear mechanism that looks a bit like this. And essentially one rotation of the smaller section is one rotation on the outside. So if you think about the amount of teeth that travel through this point here is significantly less than it would be to turn this once, and that's what gear ratio is all about. I won't get into that, there are plenty of YouTube tutorials about that if you want to learn the engineering behind it, but it's just a simple gear rig. But it's not required to know any of that for this assembly, so don't worry about it. Back to the main assembly. That's the trigger gear. So the next thing we have to do is arrange our gear train. So there are 3 gears, 2 in the middle here, and then 1 here. So the first 2 in the middle are actually the same thing. It's called the 30T gear, which just stands for 30 tooth gear. And they look a bit fancier just because I figured they look nicer when you print them. And they are both the same, like this, and they just line up on these pins here. You will notice there is quite a significant tolerance between this wall and the actual pin that it sits on. I found that was because of printing discrepancies and tolerances that I was getting. You might find that you have to modify the files ever so slightly. If you do have to modify them significantly and you need, say, a step file rather than an STL or even a SolidWorks file, by all means just drop me a DM and I'll send you them, and you can play about with the diameters to your heart's content. There's another 30T gear on the end here. Again, nothing special about it, just make sure it lines up with the other ones. And then here we have another compound gear, which this one is just called the compound gear. It does look slightly different to the trigger gear in that the trigger gear is a bit fatter on the underside and this one's a bit skinnier. Just make sure you get them the right way around because otherwise the gear ratio won't work. Again, that just sits on a little cylinder pin, nothing special. The interesting part is this bit here. So in here goes a really small gear which is known as the blade gear, which looks a bit like this. It's significantly smaller than all the other gears and you'll see that the teeth are actually a lot wider. This is intentional, and I found that if I printed them too narrow, the blade actually wouldn't come out or they might snap off because of how skinny it all is. So the important thing is when you're assembling this, just to try and make sure that the teeth on the blade line up as best you can. It doesn't have to be perfect, just try and get it as best you can. As you can see, my blade doesn't quite go to the bottom in this iteration here. You probably get a few more teeth in if you were to shove it all the way down, but it really doesn't matter. I've put a cutout down here so that you can drag the blade as far down as you possibly can without going through the model. That should work out for most people. Next up we have another little bit of sub-assembly. So the next part that we need to open is called the blade gear clamp, which is basically a T-shaped bit that looks like this, and it sits, as you can see, in the little slot in the case mechanism here. And that's just to hold it in place. The sub-assembly side of it is that this gear has to sit around a pin, and I couldn't really put one anywhere because this is the blade, this surface here. so you can't really have one sticking out, otherwise your blade won't come out. And having it loose had loads of problems. I did try and leave it loose, but it just tends to tip up or not spin correctly, so having it free doesn't really work, and you need to captive it somehow. So I got around this by having just a little steel pin. You could print this if you wanted, by all means, there's nothing stopping you, but I vowed for metal just because this particular part comes under quite a lot of stress because of the gear ratio, relative. So I would personally use metal. So you just need a little pin, and that pin gets posted through the hole in the gear clamp plate. In my design here, it doesn't actually touch, but to be honest with you, it could be like here, just glued in. It doesn't matter. As long as the cylinder is going through the whole of the gear, it does not matter. So don't worry about that. So once you've glued that down, well, glued the pin into the clamp plate, put the clamp plate in, should just slot into place like this. And that's pretty much your mechanism sorted. Make sure your elastic band is here and here, so that you get the tension between these two parts here. These teeth here connect with the teeth in the compound gear here, which then turns the rest of it. One last thing to notice before we close it all up and seal it all down is that the trigger has this weird channel section on it. Now what this is for is, I used galvanized wire, but you really want to be using some kind of like tennis racket wire or a strong, firm but flexible material if you can. I use galv wire just because it's what I had, so that's what I've linked in Thingiverse because I know it works. But anything that is, you know, not stretchy and will just not break if you pull it too hard will work fine. Essentially, there's a small hole here, post it through there, tie a knot in the back so it can't come back. You could glue like a bead on it or something if you wanted, just so it can't come back through this hole. So that string travels up this channel bit here and out through this hole here, and that's eventually what goes to a ring on your finger, what have you. It doesn't really matter. So obviously pulling that little bit of material will make this trigger move up and down. The tension will build on the elastic band that's between these two bits here, and when you release it will come back and bring the gear train with it. I will say that this does work. I have tested it multiple times, but it does require a bit of patience with the sanding, and in some cases using silicone lubricant or something. 3D printed parts can be quite rough, especially if you print them on supports or if you have a clogged nozzle or, you know, don't have ironing enabled, something like that. So please do bear with the smoothing side of it, because friction can be a real problem and it will cause you a lot more headache than you think it will. So take your time with the sanding, don't let it beat you, believe me. It's not fun, no one likes it, but you have to do it. Once you're happy with the tension and the sanding and everything, I would strongly recommend putting the cover on before you test it, just so the gears don't try and fly out. So the cover is just as it was in the original design, a piece of plastic that looks kind of like this. There is a raised surface here, just to give that little bit more gap between the top of the gears and the top of the case. I'd recommend printing it with this face down on the bed of your printer, just so that you get a nice smooth finish here, as long as your bed's level and your bed doesn't have any warp in it, and two, because digging the supports out of this is not fun. So if we just go back to the main assembly now, I'm going to put that cover on, and really at this point it's done. If you put the screws in the holes like so, you could test the mechanism to your heart's content, and just, you know, as I said, have some perseverance with the sanding, with the lubrication of it all. It does work, and the results can be really quite good. There's a stress test video in the link on Thingiverse, and that sort of shows you that you can really give this thing a battering and it will still work. But that's it really. There are some, as I said, some aesthetic pieces, so you can put, say, the side piece on and the lower piece on, and having these screw holes like this kind of leaves me open to maybe put some additional things on this. I was toying with the idea of putting like a BB gun, hidden gun on it, or maybe doing the Phantom Blade from Assassin's Creed Unity. They're later projects. Building a crossbow has a whole plethora of other challenges that are completely separate to these. But that's it. I hope this video is simple enough for you guys to understand and hopefully follow. I will do a breakdown video where I actually rebuild my prototype one in person, but I figured because of the simple design, it didn't really require as much of a long-winded video as the original one did. But as always, any questions, feel free to just mention them in the comments below, and I'll try and be as active as I can with replying to them. Or if you're on Thingiverse, just send me a DM, or comment on the actual thing itself. Remix it as much as you want. I don't sell these anywhere and won't sell them. They're meant to be free. I think people overcharge for these things, and it's just not needed. We're fans at the end of the day. We should just share this. So any problems, feel free to message me. Thanks.